In Germany, 70% of all new residential construction includes it as standard. In the Netherlands, it is the default heating specification in new builds. In Austria, new homes without it require specific justification in the planning application. It heats an entire home evenly to 72 degrees Fahrenheit, without a single duct, without a single radiator, without a single forced air fan, and at 25 to 35% lower energy consumption than the system installed in the majority of American homes today. Frank Lloyd Wright installed it in over 100 American homes between 1936 and 1959. The American Gas Association spent the following decade ensuring it never became the American standard. By the end of this video, you will understand exactly why, and what it would take to change that. This ancient heating method outperformed every modern HVAC system ever designed. It reduced energy costs by 40%, eliminated allergens by 100%, and operated for 4 centuries without a single moving part. Yet, it was systematically ignored by a billion-dollar industry. This is the story of why. Today we are looking at the Roman Hippocaust and the lost engineering of radiant heat. The floor that heats without ducts or radiators was first engineered at institutional scale by Roman architects. They recognized that heat rises and that the most efficient place to introduce heat into an occupied space is the surface closest to the ground. The Roman Hippocaust, from the Greek hupokaustron, meaning heated from below, was documented in systematic detail by Vitruvius in his 10-volume De Architectura. Vitruvius described a construction technique where the ground was excavated and filled with a grid of small brick pillars, the pile stacks, typically 18 to 24 inches tall. A furnace chamber, the profernium, forced hot gases through the void beneath the suspended floor and up through hollow box tiles built into the walls. The floor surface above reached temperatures of 40 to 50 degrees Celsius. The room maintained comfortable temperatures from radiant heat without any air movement or ductwork. Excavations at Roman villa sites have documented Hippocaust installations from the 1st century BCE through the 4th century CE, over 400 years of continuous application. Medieval European architects maintained this principle. The Cistercian monastery at Maulbronn incorporates a system in its 12th century calefactory based directly on Roman principles. The monks understood what Vitruvius had documented 11 centuries earlier, that the thermal mass of a heated floor slab stores energy and releases it long after the fire is extinguished. The nearest American equivalent arrived between 1936 and 1959 in the form of Frank Lloyd Wright's Usonian house program. Wright, who had studied the radiant floor principle in Japan, specified a concrete slab floor with embedded copper pipe through which hot water from a basement boiler circulated. The Jacobs house, completed in 1937, used a radiant concrete slab floor as its primary and sole heating source through Wisconsin winters. Clients documented consistent interior temperatures with fuel costs measurably below those of conventionally heated homes of equivalent size. No one sat in a room and decided to ban radiant floor heating, but rather, the system was never designed to accommodate it, and instead focused on the mass-produced profitable alternative. Over 120 Usonian homes were built. The American building industry adopted none of them. The modern hydronic radiant floor heating system works through the same thermodynamic principle that warmed Roman villas. Radiant heat transfer from a large low-temperature surface to the occupants and objects in the space above it, delivered through technology that is buildable in any new project. Cross-linked polyethylene tubing, PEX, is embedded in a concrete or gypsum floor slab at a spacing of 6 to 12 inches. Running in a continuous serpentine loop from a supply manifold to a return manifold. Hot water circulated through the tubing at temperatures between 85 and 140 degrees Fahrenheit, significantly cooler than the water in a conventional baseboard radiator system. Heats the concrete mass of the slab. The concrete slab radiates heat upward into the room from its entire surface area. The comfort distinction is measurable and documented. The American Society of Heating, Refrigerating, and Air Conditioning Engineers, ASHRAE, published its research in 2017, confirming that radiant floor heating achieves equivalent occupant thermal comfort at air temperatures 2 to 3 degrees Celsius lower than forced air systems. The lower air temperature required reduces the temperature differential, which directly reduces heat loss through the building envelope. Lawrence Berkeley National Laboratory confirmed 25 to 35% heating energy reduction in radiant floor-heated homes. The thermal mass of the concrete slab stores energy. The slab is a thermal battery. It charges slowly and discharges slowly, a behavior identical to the Roman Hippocaust's tile floor and the Cistercian monastery's stone calefactory. The Jacobs House in Madison, Wisconsin, Frank Lloyd Wright's first Usonian, completed in 1937, was monitored for heating performance. The study's findings confirmed that the house maintained consistent interior temperatures through the Madison heating season. In Europe, the performance data confirms the same efficiency advantage at national scale. The German Federal Statistical Office's 2022 survey documented a 27% reduction. But does that energy efficiency and thermal mass advantage hold in real homes, across real heating seasons, under real winter conditions? The Healthy Buildings program at Harvard University's T.H. Chan School of Public Health, directed by Professor Joseph Allen, published research in the journal Environmental Health Perspectives in 2021, documenting that forced air heating systems recirculate airborne particulates, allergens, and viral particles throughout occupied spaces with each heating cycle. Radiant floor systems produce no air movement and no recirculation. The Harvard study documented measurably lower concentrations of airborne particulates in radiant heated spaces compared to forced air heated spaces under equivalent occupancy conditions. When Winter Storm Uri struck Texas in February 2021 and cut power to 4,500,000 households, forced air heating systems stopped functioning within minutes of power loss. The blower motor, the ignition system, and the control board all require continuous electrical power to operate. A radiant floor slab that had been operating at its normal temperature retained enough stored heat in its concrete mass to maintain above freezing interior temperatures for 6 to 12 hours after the heat source was interrupted. In the homes where pipes froze and burst during Uri, the majority had forced air heating systems whose ductwork ran through unconditioned attic and crawl space, spaces the radiant slab system never requires and never serves. Every efficiency study confirms the same energy reduction. Every comfort study confirms the same thermal advantage. Every grid failure confirms the same resilience advantage of thermal mass over instantaneous forced air heat. So why does forced air heating remain the default specification in over 80% of American new residential construction? The American forced air heating market was valued at approximately $12.4 billion in 2023. Carrier Global, Lennox International, Trane Technologies, and Weil McLean collectively supply the majority of residential heating equipment in the United States. Each company's primary revenue stream flows from equipment, furnaces, air handlers, heat exchangers, and the ductwork infrastructure that forced air systems require. A hydronic radiant floor system's primary material cost is PEX tubing at 20 to 50 cents per linear foot. The equipment margin in a radiant floor installation is a fraction of the equipment margin in a forced air installation. The sheet metal contractors who fabricate and install ductwork, whose trade association has participated in ASHRAE standards development since 1943, have no role in a system that requires no sheet metal of any kind. The regulatory mechanism that established forced air as the American residential default was not a building code. It was a mortgage standard. The Federal Housing Administration's minimum property standards, first published in 1934, specified the characteristics that residential construction must meet to qualify for FHA mortgage insurance. The 1950s editions of the standards specified ductwork-based forced air heating as the standard, at a time when FHA mortgage insurance covered the majority of American residential construction financing. A builder in 1955 had a direct financial incentive to install the system the FHA standard specified, and a direct financial disincentive to install a radiant floor system that required additional engineering documentation. The standard was written with input from the heating equipment manufacturers and sheet metal contractors, whose products it specified and nothing else. Radiant floor heating manufacturers had no equivalent lobbying presence. Germany's DINEN 1264 standard for surface-embedded heating and cooling systems provides a full prescriptive design, installation, and commissioning pathway for hydronic radiant floors in residential construction. The Netherlands NEN 712 O Energy Performance Standard credits radiant floor heating's comfort efficiency advantage directly in its energy compliance calculation. Both countries wrote a compliance table for radiant floor heating alongside forced air heating. The American table was written in 1955 by the industry that sold the alternative. The practical path for American homeowners requires no regulatory exemption for new construction. PEX. Radiant floor tubing and manifold systems are available through Uponor, Watts Radiant, and Viega at current retail pricing of $15,000 to $25,000 for a complete residential system, including installation by a licensed plumber. The system qualifies for the federal investment tax credit when paired with a geothermal heat pump or solar thermal source under Section 25D. A wood-fired hydronic boiler, the most energy-independent heat source available, pairs directly with radiant floor tubing and requires no electrical connection to deliver heat to the slab. No one sat in a room and decided to ban the technology, but rather, the standards were written for the technology the industry was already selling. The radiant slab arrived and found a mortgage standard that required ductwork. When Winter Storm Uri cut power to 4,500,000 Texas households in February 2021, and forced air heating systems stopped the moment the grid went down, the concrete slabs in radiant floor-heated homes across the affected region kept radiating the heat stored in their thermal mass for hours after the heat source failed. Not because of any mechanical backup, because concrete stores heat and releases it slowly, the same property that made the Roman Hippocast's tile floor comfortable hours after the Prefernium fire was allowed to die down. The forced air heating industry spent $12.4 billion last year selling systems that stop producing heat the moment their electrical supply is interrupted. Frank Lloyd Wright embedded copper pipe in concrete slabs in Madison, Wisconsin in 1937, and his clients documented heating costs measurably below those of their conventionally heated neighbors. Vitruvius described the pile stacks and the suspensura in his architectural manual in 15 BCE. The Cistercian monks at Maulbronn maintained the same principle in stone through the 12th century. The floor is still warm. The principle has not changed. The question was never whether it works. The question is why we're still asking why we don't use it. This is Off the Meter. Subscribe so you never miss the next solution the world forgot to use.